I want to welcome you guys to the video lectures for college algebra. This is MAC 1105. My name is Jorge Gavillan. So just a quick reminder that chapter R is just a review, and we're going to be covering this for the first couple of weeks of class. So for R.1, we're going to be working with sets. We're going to classify numbers. We're going to evaluate numerical expressions, and then we're going to work with properties of real numbers. So the first thing is working with sets. And so if A and B are sets, the intersection of A and B, and this is the symbols that we use, A and B, is a set consisting of elements that belong to both A and B. And then the union of A and B, denoted here with the symbols, is a set consisting of elements that belong to either A or B or both. So here's an example. I'm going to find the intersection, the union of the following sets. So they gave us A. A is defined to be the set that contains the numbers 1, 3, 5, and 8. B is a set that contains 3, 5, and 7. And C contains 2, 4, 6, and 8. So we're going to go ahead and find the intersection of A and B, the union of A and B. And then we're going to find the intersection of B with the union of A and C. So here you can see that the intersection of A and B are the values or the elements that are common to both of them. And the only ones that qualify are the numbers 3 and 5. For B, the union, when you have a union of two sets, that includes the elements of both sets. So as you can see, we include everything that's in A and everything that's in B, but we don't double count. We don't put the 3 twice or the 5 twice. And then the second one, what we're going to do first is find the union of A and C. And then you can see that the union of A and C is 1, 2, 3, 4, 5, 6, and 8. And then we're going to find the intersection of that set with B, which gives us the numbers 3 and 5. Another definition, if set A is a complement of A and is denoted by, that's A bar, is a set consisting of all the elements in the universal set that are not in A. In other words, a complement of A are the elements that are in the universal set but not in A. So here, So here we're going to find the complement of a set. So if the universal set is the numbers 1 through 9, set A is defined to contain 1, 3, 5, 7, and 9. Then the complement of A are the elements that are in the universal set but not in A. And you can see that those are the values 2, 4, 6, and 8. So here's another figure. This is a Venn diagram. This is a 3-set Venn diagram. You can see the universal set is usually denoted as the rectangle. And then you have the sets A, B, and C. And when you have a Venn diagram, sometimes it makes it easier to see the union and the intersections of the sets and so on. So here in A, we have A is a subset of B. And you can see that A is completely contained within B, but it's not equal to B. And then for B, you have the intersection is actually the empty set because these two sets have nothing in common. And here, some more examples. Using Venn diagrams, the intersection of A and B is the shaded region. The union of A and B is basically both sets. And the complement of A is everything that's in universal set but not in A. Well, the next thing we're going to do is classify numbers. The integers are the set of numbers. And so the next thing is a rational number. And a rational number is simply a number that can be expressed as a quotient or a fraction of two integers. The integer A is called the numerator, and B, which cannot be 0, is called the denominator. Now the rational numbers are the numbers in a set. So for all numbers x such that x is equal to A divided by B, where A and B are integers and B does not equal 0. Now the set of real numbers is a union of the set of rational numbers with a set of irrational numbers. So here we can see the real numbers, the irrational numbers, and then the rational numbers. Within the rational numbers, you have the integers, you have the whole numbers, and then you have natural accounting numbers. Next thing is classifying the numbers in a set. So here we have a set with different values. And then, so we're going to go ahead and see are they natural numbers, are there integers, rational numbers, irrational numbers, and real numbers. So 10 is the only natural number. Negative 3 and 10 are both integers. Negative 3, 10, 4 over 3.12 and 2.15 repeating are rational numbers. Square root of 2 and pi are irrational numbers, and every single value listed is a real number. approximations, we'll talk about this more in class, but truncation, basically drop all the digits that follow the specified final digit in decimal. And then rounding, identify the final digit in the decimal. If the next digit is 5 or more, add 1 to the final digit. If the next digit is 4 or less, leave the final digit as it is. Then you truncate the following final digit. And again, this becomes a little clearer when we work this in class. Here's another table, some more review. So the operation addition is A plus B. I don't know why this keeps popping up, sorry. Subtraction is A minus B is the difference. Multiplication, so different ways to use symbols that define multiplication. If you notice in the multiplication one, we don't use X to denote multiplication. And in division, it can be a slash or the fraction bar. Now, writing statements using symbols, and so the sum of 2 and 7 equals 9. In symbols, this is going to be written as 2 plus 7 is equal to 9. The product of 3 and 5 is 15. Is always the equal. So in symbols, it's just 3 times 5 is equal to 15. Or equals 15. So we're going to evaluate numerical expressions. So first thing is that we agree that whenever two operations of addition and multiplication separate three numbers, that multiplication operation will always be performed first, followed by the addition. So this is just simply order of operations. So we're going to evaluate each of these expressions and see what the final answer is. So A, we have 3 plus 4 times 5. B, we have 8 times 2 plus 1. And then C, we have 2 plus 2 times 2. So in the first one, we're going to go ahead and multiply first. So we're going to do 3 times 20, which is 23. And B, again, we're going to multiply first. And if you notice, it doesn't matter if it comes after the addition or before the addition. And then for C, again, we're going to multiply first and then add. And then so the rules, here are the rules for operations. I'm not going to read them to you. You can go ahead and just make sure that you understand these. And mistakes are made all the time, but that's okay. That's where we're in class to try to correct those. And then for another example, find the value of the expression. So for A, we have 8 times 2 plus 3. And then B, we have 5 times 3 plus 4 plus 2. 3 plus 4 is in parentheses. For C, we have 2 plus 5 divided by 2 plus 4 times 7. And you can see D. So in A, again, we're going to multiply first. So it's going to be 16 plus 3, which is 19. In B, we're going to go ahead and perform the operation in parentheses first. So we're going to do 3 plus 4. And then we're going to multiply the 5 times 7, and then we're going to add that to 2, gives us 37. For C, we're going to go ahead and perform the operations in the numerator and also the denominator, and then we're going to go ahead and divide if we have to. And then for D, as you can see, we're going to take care of the operation within the parentheses. We have brackets and then parentheses. So we're going to take care of the innermost groups. So we're going to do the 10 plus 6, which is 16. Then we're going to multiply that times 2. And then we're going to add the 4. And then we're going to add the 2 to the 36, which gives us 38. The next thing is work with properties of real numbers. So these are some properties, and we're going to be using this throughout the course. The reflexive property states that the number equals itself. That means that A is equal to A. Symmetric property states that if A is equal to B, then B is equal to A. The transitive property states that if A is equal to B and B is equal to C, then A is equal to C. The principle of substitution states that if A is equal to B, then we may substitute B for A in any expression that contains A. So here, the first one is the cumulative properties. So we have 3 plus 5 is equal to 8, 5 plus 3. So in other words, 3 plus 5 is the same or equals 5 plus 3. And then 2 times 3 is the same as 3 times 2. So cumulative property. Now the next thing is the associative property. And here is just groups. And so you can see that 2 plus 3 plus 4 in parentheses is equal to 9. And if we change the grouping, we still get the same value. And the same thing for multiplication. So here's the associative property of addition and multiplication. Now the next one is distributive property. So you can see here that A times B plus C, or A plus B times C. So for the first one, when you do distributive property, probably the best thing to do is just remove the parentheses. So 2 times x plus 3 becomes 2x plus 6. And then 3x plus 5x is equal to 8x. And of course C, we're going to use FOIL method, which is first, outside, inside, last. There's also different ways of multiplying these, and this one, what they did was they separated into two distinct distributive properties, and then we combined it at the end. the identity properties. Now, the additive inverse property, a plus negative a is equal to 0. So the additive inverse of 6 is negative 6. The additive inverse of negative 8 is positive 8. The multiplicative inverse property, so a times 1 over a is equal to 1. So here, finding reciprocal, the reciprocal of 6 is 1 over 6, because 6 times 1 over 6 is equal to 1. So you can see here that the reciprocal is simply just the flipping of the value that you have. So for C, we have 2/3. The reciprocal of that is 3 over 2. Now, the difference a minus b is also read as a less b or a minus b, and subtraction is defined by multiplication or the addition of the inverse of the number. So a minus b is equal to a plus negative b. Now, if b is a non-zero real number, the quotient a over b is also read as a divided by b, or the ratio of a to b. Multiplication by 0 is equal to 0, regardless of what you're multiplying. Division property, 0 divided by any value is 0. A divided by a, so a is obviously a value. And so if I have 5 divided by 5 or 10 divided by 10, it's going to give me 1 as long as a doesn't equal 0. So the rules of signs, here's some rules. And then applying some of the rules of signs. So you can see that a positive times a negative is a negative. A positive divided by a negative is a negative. A negative times a negative is a positive. A negative divided by a negative is a positive. Now, cancellation properties. AC is equal to BC implies that A is equal to B if C does not equal 0. And then AC divided by BC is equal to A over B as long as B and C do not equal 0. Zero product property, if A and B is equal to 0, then A is equal to 0, or B is equal to 0, or they're both equal to 0. I'm going to use this when we solve equations. So these are some quotients. You can just look at these over and just make sure you review them. So that's what we're going to be doing with Chapter R. Now, in this example, we're going to use the least common multiple to add two fractions. So we have 8 over 15 plus 5 over 12. And so there are different ways of doing this. Perhaps the easiest way is the way that they do it here, which they find a value that's common to both of them. In this case, is 60. So they multiply the top and bottom of the first fraction by 4 and the top and bottom of the second fraction by 5 to get 60 in the denominator. Once the denominator are equal, then we can go ahead and add the numerators. And then, of course, we can reduce. And that's the end of R1. Thank you.